In the question number 11, a block of mass 5 kg is placed on a plank of mass 10 kg, which is placed on a smooth horizontal surface. As shown in figure, if a 100 Newton force is applied on the plank, then acceleration of the plank with respect to the ground. This is very important line, with respect to the ground. Coefficient of friction between block and plank is mu s, mu k, both are equal, 0.4, and value of g you can take 10. So I am going to solve this question. So थोड़ा सा seriously देखते हैं. Suppose if I go for the maximum frictional force, so I can write coefficient of friction and total mass m1 plus m2 into g. So this is the concept that I will use. If I say maximum force for common acceleration, so without any hesitation I can write maximum force for common acceleration. That is what I am trying to explain. That is 0.4, because this is the coefficient of friction and I need total mass 5 plus 10, that is 15, into the value of g is 10, that is 60 Newton, right? So the maximum force for common acceleration as per the calculation is 60 Newton, but force applied is greater than 60 Newton because this is 100 Newton. So friction will be kinetic, right? If friction is kinetic, then 5 kg block will move. So if I use the kinetic friction mu k into n, mu k is 0.4 and the mass of upper block is only 5 kg because there is a friction between 5 and 10 kg. So 5 into the value of g is 10. So I have 20 Newton frictional force and that will act in left side. So if I go for acceleration, I will write 100 Newton on the right hand side. As I said, I will take positive sign along with the direction of motion, and minus 20 kinetic friction will oppose. So that will be the minus 20 and mass is 10, right? Because question is asking to us, if a 100 Newton force is applied on plank, then acceleration of the plank with respect to the ground. So that will give you 8 meter per second square. So this is the final acceleration. So my option number 1 will be the right choice. So let's move on. Question number 12. In the question number 12, an arrangement is shown in figure if all the surfaces are smooth and system is released from rest. Then the relation between acceleration of blocks P means AP and QAQ will be. So we can solve this question by using constraint relation. Let's suppose if I consider X be the displacement of movable pulley and y is the displacement of block P. Okay, initially if I consider this length is L1 up to this and another this length is L2. Let's suppose this pulley will move here. अगर ये यहाँ तक आ जाती है, then as per my consideration, this will be X and this will be X. So total length now L1 plus X and this length will be L2 plus X. But there is a change in position of this block. Block will move here. According to my consideration, this is Y. So if I go for the constraint relation, then we can write the initial length was L1 plus L2 and now this length will becomes L1 plus S, L1 plus X, and for block side L2 plus X, but due to the change in position of the block it is only Y, so we'll subtract Y minus Y. So L1 plus L2, L1 plus X plus L2 plus X minus Y. L1 will cancel out and you will get 2x equal Y. So 2x equal Y. You know Y is the displacement of the block P and X is the displacement of movable pulley. So when I will differentiate on 2 times, then you will get acceleration of the block P, that is equal 2 times of acceleration of the Q. So my option number 3rd will be the correct choice. So let's move on. Question number 13. In the question number 13, a force of XI 2 by J cap Newton is applied object of mass 10 kg. Force displaces the object from position A. From position A, that is 1, 0. This is x1, y1. If I say to the position B, 3, 3. So I can write x2, y2, right? Then the work done by the force is and x and y in meter. So this is a simple question. Work done is given by F dot dr. I need first force, so I can write F x I cap, F y j cap, and the position vector you can write dx I cap, dy j cap. So when you will take the dot product, you can write fx dx because I dot I is 1 and fy dy. So if I use the integration dw, so now I am going to use the value of fx. You know, when you will take dot product, you will get fx dx plus fy dy. Now I need the value of fx because force is given xi cap 2 by j cap. So I can take coefficient of I cap, that is x dx, and limits are, because the position is starting from 1, 0 to 3, 3. So I need x1, that is 1. I need x2, that is 3. And similarly for y, the component of force along y is 2 by j cap. So you will write here 2 by dy. I need y1 and y2. y1 is 0, y2 is 3. So limits are 0 up to 3. So when you will integrate, now it will becomes very easy. So you will get 13 joule. So this is how you can solve. So my option number 3rd will be the right choice. So let's move on. Question number 14. In the question number 14, a block of mass 10 kg released from top of rough inclined plane as shown in the figure. If the coefficient of friction between the block and inclined plane is 1 by 4, then total work done, look at total work done means work done by all kind of forces, right? Block by all the forces acting on it till it reaches the bottom, and you can take the value of G is 10. In this question, first I am going to use something interesting. You know the value of sine 37, you know 3 upon 5, and you know the value of cos 37, right? That is 4 upon 5. So if I use this just like a triangle, so we can write, because sine is perpendicular upon hypotenuse, so hypotenuse will be 5, and cos theta is base upon hypotenuse, so you can write here 4. So I have the value of 3, 5 and 4, all kind of separations, right? So if I go for the work done by mg, because if you are looking to find the net work done, so first you will calculate work done by mg, yani weight, and work done by the friction force, and work done by the normal force. So when you will solve work done by mg, you know the formula of work is force into displacement into cos theta, and theta is the angle between the direction of force and the displacement. In the case of weight, weight will act in downward, and you can take the displacement is 3 for this case. So you have to be very careful. So I will write mg is the force, 3 is the displacement, and cos theta 0, because the direction of force of mg and displacement both are in same direction, that is 3. So when you will solve, you will get 300 joule. This is the work done by weight. And if I go for work done by the normal force, you know normal force will act because that will be the perpendicular to the surface of contact, and block will slide in downward. So when you will observe the direction between normal force and displacement, you will get the theta 90. So I will write normal force, displacement is the 5, this one, and cos theta will be 90. So you will get 0. Work done by normal force is 0. And now if I go work done by friction force, in the case of friction force, first I will write the friction force mu into n. Second is displacement, that is 5. Because friction force will act on right side, because friction force will oppose the relative motion. So mu n into 5, I need cos theta. So that is 180 degree, as I said. So when I will place the value mu mg cos 37, mg cos 37 is the value of normal force, right? Into displacement is 5, cos 180 is minus 1. You will get minus 100 joule. Now I have the three values. Due to mg 300 joule, due to normal 0, due to friction minus 100 joule. So when I will place all values in my relation number 1, so net work done will be 300 due to mg, due to friction is 100, due to normal is 0. So I had 200 joule. So that is what you can find the value of net work done. So by this calculation, I can say my option number 1 will be the right choice. So let's move on question number 15. In the question number 15, if force F is this, acting on the particle which is moving from this position to this position, if work done by the force on the particle is 0, then value of B is. This is another good question and simple question. So F dot dr is equal to 0 according to the problem. I need force, that is 3I minus 4j plus bk cap, and I need displacement. And you know, for the displacement you will write final position minus initial position. Final position is 2j cap, 3j cap, because coordinates are 2 to 3, and initial position 0I cap minus j cap plus k cap. So when you will place the value of final position and initial position, you will get 2I cap, 3j cap, and 2k cap. So when you will place the value will be here 2I plus 3j plus 2k, and that is equal to 0. So when you will take the dot product, I dot I1, J dot J1, K dot K is 1, you will get the value of B is plus 3. So this is how you can solve. So my option number 4 will be the right choice. So let's move on question number 16.